Okay, let's unpack this. We are diving far past the simple chatbot
Oh,
today.
way past it.
We're getting into the world of true AI agents, systems that can actually reason and take action.
And handle these complex multi-step tasks all on your behalf. I mean, think about the potential there for automated workflows, for analysis, for actual
It's
execution.
a completely game-changing level of power.
And that power, well, it comes with a monumental, immediate, and frankly, a non-negotiable catch,
Yeah,
especially if you're operating in any industry that touches sensitive data. We're
right.
talking about protected healthcare information, proprietary financial analysis, classified defense intel.
Privileged legal document.
Exactly, all of it.
So that's our mission for this deep dive. We're going to figure out how developers and engineering teams are actually harnessing this power,
Hmm.
this agentic AI, while keeping all that sensitive data completely private. We've gone through the source material, and we're going to lay out the specific architecture, the unexpected hidden risks, and really the practical, actionable steps you need to build these systems securely from the ground up.
And the core conflict driving this whole thing is it's pretty straightforward, really. Agentic AI is this undeniable leap forward in automation. But for anyone in these highly regulated spaces, healthcare, finance, legal relying on consumer-facing LLMs is
The
just
deal breaker.
a massive non-negotiable deal breaker. Regulatory and privacy requirements just instantly eliminate those public solutions from the equation.
So before we even get into the architecture, I think we need to really appreciate the severity of this privacy crisis. Let's use that healthcare example you mentioned because it illustrates the risks just so perfectly.
Okay, yeah, let's run that scenario. So you have a developer, right? They're well-meaning. They want to use this incredible AI technology to, say, summarize complex medical documents.
Or maybe draft a sensitive email based on a patient's recent visit.
Perfect. So they could easily take those documents and just feed them directly into a consumer-facing web app that's fronting one of the big Gen AI platforms.
It's fast, it's easy.
And they probably get decent results back, too.
But the immediate flashing red warning siren is, do not do this.
Absolutely not. I mean, the most obvious problem is that you'd be sending protected healthcare info, PHI, to a third party.
To the public AI provider.
Exactly. With no business associate agreements, no proper safeguards in place, that is a clear, expensive, and immediate HIPAA violation.
And this isn't just a medicine problem. If you're in finance, legal, defense, that high consequence data means public APIs are instantly off the table.
Right.
Which brings us to the tech itself. We should probably clarify the difference between reactive and agentic AI because the action-oriented nature of the agent is what makes this privacy risk so acute.
That's a great point. Historically, and I mean, when we say historically, we're talking about models from maybe 12, 18 months ago, LLMs were fundamentally reactive.
You ask a question, they give an answer.
That was it. You'd enter a prompt, they'd respond with text. That was the extent of their capability. They were basically, glorified text completion engines.
But agentic AI is a whole different ballgame. These systems have reasoning capabilities. They can break down a goal into subtasks, and they can actively act on your behalf by invoking tools.
They have genuine autonomy in a workflow. So, for example, an agent could read a document, decide it needs to query an external database, then draft an email based on both of those sources.
And then send it through an internal API.
That's the critical difference. So if you connect these powerful action-oriented agents to the public cloud, where their calls and their data processing aren't strictly controlled, you just can't work with sensitive data. It's impossible.
The risk of, what, unintended data leakage.
Yeah, where a tool call accidentally exposes PII or just an explicit regulatory violation, it's too high. The moment that data leaves your network perimeter, you lose all control and, crucially, you lose compliance.
So how do we solve this? How do we keep the incredible power of the agent without inviting all the risk of the public cloud?
Well, this is where it gets really interesting.
Because the answer is in these private agentic flows, meaning the agents that act on your behalf are operating entirely on infrastructure you control.
Safely tucked away behind your firewall.
Right. And to get that level of security, you need a very specific architectural stack.
And developers are building these private flows in 3 distinct layers. Each one addresses a different part of the problem: the data processing and the action.
Okay, so layer 1 is the foundation layer. This is the core engine. This is the large language model itself.
Crucially, it doesn't matter if it's a closed source model you license or an open source one you download. What matters is where they run.
Okay.
The model has to run entirely on your infrastructure, whether that's, dedicated on-premise hardware or securely isolated within your private cloud. That requirement for isolation is the absolute baseline.
That sounds like a pretty significant operational hurdle, though.
Yeah.
Isn't that drastically more expensive or complex than just, making an API call to a massive public service?
It absolutely is, and that is the architectural trade-off. Running these big models privately requires a ton of compute power, dedicated teams for maintenance, for patching, security controls.
But the alternative is worse.
For highly regulated industries, the cost of a data breach or a regulatory fine, which can run into the tens of millions, it makes that investment non-negotiable. Isolation is security.
Okay, so we have the isolated model. That brings us to layer 2, the augmentation layer. This is the layer that takes that general model and grounds it in your specific private reality.
This is where we see the intense use of retrieval augmented generation, or RA.
Right.
So here you'll find things like your vector databases, which are these specialized data stores optimized for finding relevant info really quickly, and maybe some fine-tuned adapters. The function of this layer is vital. The agent retrieves info from your private knowledge bases, your encrypted document repositories.
So wait, RAG isn't just about making the answers better, it's also a security mechanism.
Precisely.
Mm.
If we connect this back to layer 1, RAG fundamentally solves the problem of embedding sensitive data in the model.
How so?
Well, instead of fine-tuning the LLM itself with all your sensitive documents, which literally bakes that data into the model's weights, you just use the LLM for its reasoning, and RAG handles the private context.
Ah, I see.
The agent queries your private data through the vector DB. It pulls only the necessary snippets, and it feeds those snippets to the LLM as context for that one specific query. The private data stays completely out of the core model weights.
That is a perfect technical solution to that data embedding risk, and a brilliant way to keep costs down compared to constantly fine-tuning these massive models.
It absolutely is. And that brings us to the final layer, layer 3.
Yeah.
The action layer.
This is where the agent earns the name Agentic. The action layer is where all the tools and internal APIs that the agent needs to use, where they actually live. So when the agent reasons, I need to confirm this user's identity, or I need to log this transaction, this is where it happens.
And those calls are happening internally, inside your trusted environment. The agent isn't calling some public banking API, it's calling your own secure API gateway to get the task done.
Which ensures the entire workflow is monitored, logged, and contained.
Exactly, all within the necessary compliance perimeter.
Okay, so we've built this beautiful 3-layered system. The model, the data retrieval, the actions, it's all inside our secure perimeter. We've eliminated the public API risk, job done, no risk left.
You'd think so, wouldn't you? But what's fascinating here is the assumption that just being behind a firewall removes all the potential risks. It absolutely doesn't. And developers building these systems really need to understand these critical, subtle nuances that persist even within a private system. If you ignore them, you can still have catastrophic compliance failures.
Okay, let's dig into those. What's the first big hidden risk that remains, even when everything is kept private?
It relates directly to model training specifically when you do decide you need to fine-tune an LLM. While RAG helps, sometimes you need to train the model on, say, proprietary processes or structural information.
Right.
When you fine-tune an LLM using sensitive private data, that information gets embedded right into the model itself during the tuning process.
I see. So the model itself becomes a repository of sensitive information.
Exactly. And even though the model infrastructure is private, if an unauthorized party gains internal access, say, a compromised account or just internal misuse, they could potentially use techniques like model inversion attacks to try and extract that embedded private training data.
So the model weights themselves become a liability.
They do.
Wow. That elevates the internal security requirements significantly. What about the legal and compliance side? We talked about HIPAA, but what happens when data needs to be removed?
That leads right into the second major risk: regulatory compliance around data removal. The right to be forgotten under GDPR, or specific deletion requests under HIPAA. So when a customer or a patient requests that their data be deleted, the task of extracting and removing that personal data becomes incredibly complex when it's been embedded in the model weights through fine-tuning.
But if you delete the source documents, isn't that enough?
Not really, because the model has already learned from that data. It's fundamentally altered its statistical properties. The source material notes that current extraction techniques, they're often called unlearning, are imperfect, they're resource intensive, and they're still evolving.
So it's hard to prove you actually removed it.
It's incredibly difficult to selectively reverse training without just degrading the model's overall performance. It makes true compliance a severe headache if you have PII baked into the model.
And finally, there's a risk that exists no matter how perfect the architecture is.
The human factor.
The insider threat.
Right. And we need to be clear here. This isn't always about some malicious actor trying to steal data. It also covers the risk of misuse or just accidental exposure of data by someone internally who has legitimate access.
A careless user.
A careless internal user, or one who doesn't fully understand what the agent can do, can still cause major compliance violations through a simple error or by giving the agent too many privileges.
Okay, so now we know the stack and we know the remaining internal risks. For the developer or, the learner building these systems, we need practical, actionable steps to solve for those risks. What are the three main mitigation strategies?
Well, the central idea is you have to stop the sensitive data from ever becoming a risk in the first place. Or at the very least, ensure any exposure is minimal and traceable.
Which leads to fix number one, and the sources highlight this as absolutely mandatory. Anonymization.
Yes. You have to scrub any personally identifiable information PII before it ever touches the LLM, the augmentation layer, or the fine-tuning process.
And this is more than just blacking out names on a document.
Oh, yeah. This often involves pretty sophisticated techniques. You might replace names, addresses, or identifiers with unique, non-reversible tokens or hashes before the data is sent to the model.
So the LLM only ever sees the generalized structure and content, not the actual person involved.
Exactly. This ensures that even if a model inversion attack somehow happens, the data that gets extracted is useless because it only contains tokens, not real-world identities.
But doesn't heavy anonymization sometimes reduce the utility of the AI? If you remove all context, how does the agent successfully summarize a file about Jane Smith's account?
That's the exact trade-off you have to manage. You have to make sure the anonymization process retains the structural data needed for the task, like knowing client A is different from client B, even if you don't know who A or B really is.
So the anonymization process has to be tailored.
It has to be tailored to retain maximum utility while achieving minimum identifiability.
Okay. Fix number two is all about control and accountability. Access control.
Implement extremely strong role-based access controls. The agent itself and the human users interacting with it should only have the permissions they absolutely need. And crucially, you need comprehensive logging.
Everything.
Log every prompt, every interaction, every query, every data retrieval. This isn't just a security best practice, it is vital for creating verifiable compliance trails if regulators ever come knocking.
That log becomes the official record of why the agent accessed data and what it did.
Precisely. It provides the necessary chain of custody for sensitive data within that AI workflow.
And the final, highly practical solution is data minimization. This ensures that even if there is a breach, the scope of exposure is incredibly limited.
This is the principle of least privilege, but applied directly to AI workflows. Only grant your agents access to the absolute minimum data they need for their specific tasks.
The example from the sources was perfect for this.
It was. Don't give an appointment scheduling agent access to full medical histories when all it needs are patient names and availability data.
The agent's access scope should be task-specific and narrow.
Exactly. If the task is scheduling, the scope of data access must be limited to scheduling data. This significantly limits the data surface area available to both internal misuse and potential exploitation of the agent.
So if we connect all of this, the architecture, the risks, the mitigations, to the bigger picture, it becomes so clear why developers are doing all this complex work.
Right.
This shift to private agentic flows, it's not optional for major regulated industries anymore. It's a pure necessity driven by business requirements.
It's totally necessary. This isn't theoretical work. Developers are building and deploying these private agent flows in the most regulated industries on Earth right now because the need for automation is immense.
But the tolerance for risk is zero.
Zero.
Take healthcare, for instance. We know developers are building agents to help doctors summarize patient histories, track statuses.
All that administrative burden.
Yeah.
The value is clear, but the genius is in the implementation. The agent retrieves data from electronic health records and references medical research, but all of that data never leaves the internal network.
So the value is provided, but the compliance perimeter is totally intact.
And you see the same strict necessity in financial services. Teams at major banks are using agents for rapid fraud detection, complex regulatory reporting, analyzing massive streams of transaction data.
And all of that customer transaction data has to stay within their secure infrastructure.
Of course, a public model can't ingest that data for training or even temporary analysis, and the risk of exposing proprietary algorithms is also just too high.
Then you have the legal sector. Law firms are building agents to search huge private case law libraries, draft contracts, find precedents from their internal databases.
Which hold privileged client information. Confidentiality is the foundation of their entire business. The system has to stay contained. They're using private agents to gain speed and insight, but the information security requirements are absolute.
And maybe the most demanding sector of all, government and defense. The stakes are the highest there.
I mean, if you're working with intelligence or defense, the need for security is total. Agents are required to analyze classified documents, connect dots across highly sensitive data sources, maybe even operate at the edge in secure environments.
So for those applications, consumer LLM services aren't even a consideration.
Not even on the table. Private agentic systems, often using open source models they can fully control and inspect, are the only operational choice.
So what does all this mean for you, the learner? I think it's that the development community saw the immense value agents provide, the ability to reason and act automatically, and they had to find a secure way to implement them.
Right. And this private agentic architecture is the resulting blueprint. It's the necessary plan for any application that handles sensitive, high-stakes data.
The teams who adopt this understand that the value agents unlock is worth the significant architectural investment.
They understood that the private approach was the only path to meet their compliance obligations while still leveraging this cutting-edge AI capability. The future of enterprise AI is not public consumption. It is private execution.
And this shift is happening rapidly, but quietly, inside these regulated systems. As AI becomes more and more integrated into these critical workflows, moving from just summarizing to actively taking action, the question is no longer, should we go private?
The question has changed.
It's now, what is the acceptable performance and cost trade-off we must accept to build our agents privately and securely? This architectural evolution isn't a choice for major industries. It's the required path forward for responsible, compliant AI.